Hi guys, so today we're going to go over the chapter 5 practice worksheet that is on your module for week number 5. Remember, this isn't worth any points. This is mainly for your benefit. You can print it out and practice with me. Okay, so the first one is just doing our Lewis dot symbols. These ones are like the super easy one. You figure out where the element is located on the periodic table, and then from there you find out how many valence electrons it has, and you apply those to your Lewis dot symbols. So I'm Googling a periodic table right now. There's some really, really good periodic tables out there. But let's do this one. Okay, so I'm going to look for my first one, and the first symbol I'm going to look up is going to be magnesium. Okay, and let's move this a little bit more that way. Magnesium, Mg. So magnesium's right here. It's located in column number 2. So therefore, it's going to have 2 valence electrons. And I'm going to apply these going 1, 2. Simple as that. I'm going to look for calcium. Calcium is also in column number 2. So therefore, it's going to have 2 valence electrons. And we're going to apply those going 1, 2. Okay, notice I'm not adding all the previous ones, right? I'm not adding the inner or the core electrons. I'm only adding the outermost electrons. Let's move on to aluminum. 1, 2, skip a few, and boom, right here in aluminum, column 13 or group 3A, whichever way that you look at it, it's going to have 3 valence electrons. So we're going to apply 1, 2, 3 valence electrons to it. Okay. The next one is SB. So this is tin. So we're going to look for tin. It's right about here. Or, ooh, I called it tin. My bad. Antimony. So this is antimony, SB. And SB is in column 15 or group 5A. So it's going to have 5 valence electrons. So we're going to apply those as 1, 2, 3, 4, and 5. Okay, so those ones are going to group together right there, those two. Let's look for bromine. Bromine is right here. It's in group 7A or group 17. And that means it's going to have 7 valence electrons. So let's apply them. 1, 2, 3, 4, 5, 6, 7. Okay. Now, last but not least is krypton, and krypton is right next to bromine, and it has a full octet, which means it has 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. Now remember, when applying these, okay, you want to make sure that you're able to make a line between your valence electrons, and only the ones that are grouped together. Okay, so this tells me that krypton has a full outer shell. It cannot make any bonds. Bromine has 1 electron available for bonding, so it can make 1 bond. Antimony has 3 electrons available for bonding, so it can make 3 bonds. Aluminum has 3 available for bonding, so it could also make 3 bonds. The difference between aluminum and antimony is antimony has 2 extra electrons. So what that means is antimony is not going to lose all of these valence electrons. It has 5 valence electrons, right? So this one has 5, while this one only has 3 valence electrons. It takes more effort to get rid of 5 valence electrons than it is for it to gain 3 valence electrons. So therefore, when this does decide to turn itself into another bond, or bond with something and turn itself into an ion, it's going to have a -3 charge. While aluminum, it's going to take more effort for it to gain a whole bunch of electrons to fill its octet. So it's going to have to gain 5 to fill its octet. that takes too much time, too much space, too much effort, right? So it's just going to lose 3, and it's going to get a positive 3 charge. All right, let's look at these ones and create the Lewis dot symbols for these ions. Okay, I'm going to look for calcium. Calcium's right here, as you can see, and then I have calcium right here as well. And I want to create that Lewis dot for it. Well, calcium just lost 2 electrons. So the only way, actually not the only way, but the best way to represent that is I'm going to look for calcium right here. It lost 2, 1, 2. So now I'm here at argon, right? And you could represent it by putting argon in parentheses, but that's not going to really work for us. So we're just going to put calcium with a +2 charge. There is no dots that are going to correspond with that one. Same thing with bromine and oxygen. They've all lost their valence electrons. Okay, so make sure you represent them like that. Like the other way that, like I said, you might see it, you might see this, where you're gonna have argon, right? And but I don't really like that one because that one's confusing. I have seen it before. Don't do that, actually. Don't do that. It's too confusing with the steps. All right, so let's go into our ions right here, the following. It wants us to name the following monatomic ions, so naming our ions. Okay. The first one, K, is a metal. So with metal, you keep the name as is. So this one is just going to be potassium ion. That's it. With metals, you keep the names as is. With elements that are transitional metals, you want to indicate the charge inside of parentheses if they have multiple charges. We learned in our PowerPoint that zinc and silver, I believe, only have 1 charge associated with them. So you're just going to write zinc and then ion. You might see it though like this to indicate that it's a zinc 2. However, it's already going to be known because it is a fixed charge. All right, iron has a +2 with it, and I'm going to erase this because this is what I want. Okay, I want you to be able to know that this has a +2 charge. Okay, iron has a +2 or a +3 charge to it, so we're going to write iron, and this one has a +2, so with a number 2. This is iron with a +3 charge, so you're going to write it as iron with a 3 right there. Now this one right here, this bromine, has a -1 charge, so this is a non-metal. And with non-metal, you're going to end it with an "ide." They're going to end in "ide." So this is not going to be bromide. Right? And that's how we know that it's an ion. It's not bromine, it is bromide. Oxygen is going to be oxide. Okay? So they end in ides. To name the following polyatomic ions, this one's going to be more of a memorization. So looking into your charts and figuring out what the name is it nitrate or nitrite? Those kind of things. So if you guys recall, I did say in one of them, when we're looking at the ones with oxygen, right? If you ate more oxygens, you're going to end in ate. If you're still hungry, you're going to be like, my stomach hurts. So this one's going to be nitrate because it has more oxygens. And this one's going to be nitrite because it has less oxygens. Okay, so these ones, go ahead and find those on a polyatomic ion sheet. Now it wants us to name these ionic compounds and place them together. So we're going to do just a few here. Okay. Um, let's look at this one. It's iron and chlorine put together. And we have the same thing here, iron and chlorine put together. The difference is that chlorine in this one has 2 chlorines and this one has 3 chlorines. So how do we distinguish the name? How do we know what iron we have? Right? So remember, your total charges have to equal 0. So when you add up these elements, the total charge has to equal 0. And I'm telling you that I have 2 chlorines. Chlorine, when we look at the periodic table, okay, it's right here. It's in group 7. So therefore has 7 valence electrons, which means that it can make 1 bond. And it is a nonmetal, so it's going to have a -1 charge. So chlorines have a -1 charge. There is 2 of them. Okay, so now I have a total of a -2 charge for chlorine. So I have X plus -2 has to equal to 0. So what is my X going to be in order for it to equal to 0? X has to equal to 2. So my charge for this iron is going to be 2. So I'm going to write iron 2. And this is chlorine, which is a non-metal, and non-metals end in "ide". Iron 2 chloride. Notice that I left a space here on purpose. No space here, but there is a space here. Okay, so that's for my iron 2 chloride. We're going to do the same thing to find the charge for this iron with the chlorine of 3. Remember, chlorine has a -1 charge. There is 3 of them, so that's going to give me a total of -3. So it's going to be X, which we don't know the charge of iron, plus -3 has to equal to 0. The charges have to cancel each other out. So therefore, X is going to equal to a +3. So my charge is going to be iron 3, Roman numeral 3, and it's going to end in chloride. Ide. Okay, so the same topic is going to apply for the rest of them, making sure that your charges cancel out with each other. I want us to do this one only because it looks difficult, but it really is not difficult at all. Okay, so we have aluminum 2 and a carbonate group, and we want to be able to write these down. Okay, aluminum is a metal, carbonate is a polyatomic ion, and I'm just going to write this as aluminum carbonate. And nothing else. Okay, notice that the carbonate ends in 8. Okay, and then aluminum, I just left it as is because it is a metal. Okay, so this is my metal. I'm not going to change it. Keep the same name. Keep it as is. And then my polyatomic ion, that's one of those that you memorize, but we know it could be carbonite or carbonate, but it's an O3, and carbonite is going to be an O2. Okay, so it's a aluminum carbonate. We don't do anything with these numbers because when we write these down, both of these have fixed charges. That means that the charges are not going to change. So I don't need to indicate that charge in the name because the charge is not going to change. All right, write the formulas for these ionic compounds. Okay, so now we have a couple different ionic compounds. It's given to us in the name, and now we want to write the formula for them. So let's do ammonium carbonate. Okay, so ammonium is NH4 and carbonate is CO3. Now, to try to figure out the charges of each one of these, we actually have to look at a polyatomic ion list. So I'm going to Google polyatomic ions for the most common ones. Get some images going, and then we should be able to answer a few of these. Let's see. All right. So here we got a couple of polyatomic ions. I'm going to look for carbonate. Here's ammonium. Ammonium has a +1 charge. So we know that this one makes a +1 charge, and carbonate makes a -2 charge. All right. So what do we do from here? Now that we know the charges, how can we apply this? I love that this one came up because now what I'm going to do is called the crisscross method. So I'm going to bring that 2 down here, and then I'm going to just bring that 1 down here. And so now I could rewrite this as NH4, and there's going to be 2 of these ammonium ions, and carbonate, there's only going to be 1. So this is called the crisscross method. It's a very simple, easy method to figuring out the charges that are going to be associated when you combine them together. So -2 and a +1, just crisscross, and you get this little figure right here. Okay, super simple, super easy crisscross method. Okay, let's look at one more here. Let's do lead nitrite. Okay, so lead is Pb, and this lead happens to have a +4 charge. So I'm going to put a +4 so I don't forget. And this is nitrite. So if we look for nitrite on here, it is an NO2 with a -1 charge. Right? So I'm going to apply that crisscross method. So this was a -1, so I'm going to bring that 1 down here. And this is a +4. I'm going to bring the 4 down here. I don't bring the charge, I just bring the number. So this is lead. I only need 1. And my nitrite, I need 4 of these molecules. So lead nitrite. All right, now let's do covalent bonding. Name the following covalent compounds. So this one you have to now have your, what's it called? Give me a second. Know your prefixes that are going to be associated with covalent bonding. So example, it's like mono, di, tri, all those different prefixes. Let me open this one up in a new page right here. So the first one that we see here is phosphorus and oxygen, and we're going to be using these prefixes in order to name them, right? So we have phosphorus, and there's 2, so this is going to be diphosphorus. And we have 5 oxygens, and if we look for number 5, that's penta, and it's going to be pentaoxide. And that's for this top one right here. I wrote a little bit too big. So if I wanted to answer this one, I'm going to answer it up here. So this one is nitrogen and chlorine. There's only 1 nitrogen, and you'll notice that the number 1 is mono, but I'm not going to say mono nitrogen, right? We actually, if for the first one, if it's just 1, we don't say mono. We only say it if it's the second one, if the second one is 1. So in this case, I'm just going to say nitrogen tri, right? Because 3 is trichloride. Nitrogen trichloride. Okay. So use your prefixes. It's really, actually, I think it's one of the easiest namings that we have. So here we go. Right here is an example of the mono one. This one's going to be carbon monoxide. Okay. That we indicate that we have 1 oxygen only. All right, so use prefixes here. Okay. And with that, it was the ones that you see on this list right here. Okay. Write the empirical formula for the molecular and the molecular formula for the covalent compound shown. So this is oxalic acid. So we want to write the formula down. We have to figure out how much of everything we have. So in this case, I have, it's going to make it a little bit messy, but let's do carbon, oxygens, and hydrogens. For carbons, I'm going to have two carbons. And for oxygens, I have 1, 2, 3, 4 oxygens. In hydrogens, I have 2 hydrogens. So a formula, the molecular formula is C2O4H2. This is the molecular formula that's used to represent oxalic acid. Now I want the empirical formula. Empirical is the lowest ratio possible, right? So these are all divisible within by 2. So I'm going to divide all of these by 2, and I'm going to get CO2H, and this is the empirical formula. Right. Identify each compound as ionic or covalent and name each compound. So if you recall, ionic is metal plus non-metal, and covalent is equal to non-metal plus non-metal compounds. So here I have zinc, which is a metal, plus oxygen, which is a non-metal. And if I look here, metal plus non-metal, this is going to be ionic. Let's go to this one. This one here, I have a phosphorus, which is a non-metal, plus bromine, which is a non-metal. So therefore, I have a covalent compound. So just identify what's your metal and what's your non-metal. You can always look at your periodic table, and it distinguishes your metals from your non-metals for you. Okay. Indicate whether the following compounds are likely to dissociate in an aqueous solution, and how can you tell? So the word dissociate means to break apart in its different ions. So to break apart in different ions. Okay, so if we're talking about ions, now we're going to be talking about something that is ionic, and something that's ionic is going to be able to break apart. So you're going to have a metal plus a non-metal. Right, so here we go. Potassium and chlorine is a metal plus a non-metal. Calcium bromide, metal plus a non-metal. So this is going to break apart. You're going to get potassium with a +1 charge, and you're going to get chlorine with a -1 charge associated to them. Right? They have broken apart. So that means, yes, it's going to dissociate in an aqueous solution. We can tell because it's a metal plus a non-metal, it is ionic. So how can we tell? Ionic compounds dissociate in water. Okay, they dissociate in water. Right, so this one's going to dissociate as well. You're going to get calcium with a +2 charge, and you're going to get bromine with a -1 charge, and there's 2 of them roaming around. Here you have carbon dioxide, which is a non-metal plus a non-metal, so this will not dissociate. Okay, so this is a covalent compound. I'm going to shorten this for compound, so it won't dissociate. Right, and I'll let you guys figure this one out. Write the ions that each acid would form in an aqueous solution. So it wants to know the dissociating ions. Okay, so in this case here, you're going to get hydrogen plus chlorine. Okay, you got to make sure that you put the correct charge. If you don't know the charge, you have to go back and look at the polyatomic ion sheet for these, which was right here. So let's use that to answer HNO3. If I'm going to look for nitric, NO3, it's right here, nitrate, right? And it has a -1 charge. So this is going to associate into hydrogen plus nitrate with a -1 charge, right? And you're going to do that for the rest of them. So like example, chromate has a -2 charge. So you're going to have, let's actually do this, plus your chlorate with a -2 charge right there. Wait, oh no, the incorrect one. Let's see, chlorate, chlorite. Oh, I did chromate. So perchlorate has a -1 charge. Right, -1. I was gonna say that's not going to be balanced. So if you guys want to know what went through my head to figure out that there was an error and had me double check my work, it's the fact that a -2 and a +1 does not equal 0. So that would have meant that the formula was incorrectly made. So that caused me to double check my work, and I found out that I used chromate instead of perchlorate, and this is a -1 charge. All right. Name each of the following acids. So when naming acids, remember we're going to use hydro at the beginning. So if you see H, you're going to have hydro. Okay. So this is hydrofluoric acid. Right. And the naming, it's going to end in ic. So the name ends in ic. Okay. Now there's some exceptions to these, like your organic acids, but for most of these, these are your non-organic acids that you're going to be naming. So nitric acid or nitrate acid, those kind of ones. There's also differences in binary acids, that means acids of 2, and then your tertiary acids, acids of 3. Okay. So for example, you have HNO3. Hydronitric acid is not really what we call this, so this one is just like nitrous acid. Okay. All right, you guys, so I hope that this video helped you guys a little bit. If you guys see any errors or typos on it, feel free to message me and I'll get them fixed. All right, ciao.